V-Series and Medium Systems family represents 25 years and 6 generations of continuous compatibility and investment protection. To celebrate this anniversary, we trace the history of the V-Series from its beginnings. Burroughs Corporation was primarily an adding and accounting machine company until 1956, when it purchased the Consolidated Electrodynamics Corporation of Pasadena, California. In doing so, Burroughs became a competitor in the then-fledgling computer industry. By the early 60s, Burroughs' Electrodata division had adopted a revolutionary computer design philosophy. The resulting B5000 and its successor, the B5500, revolutionized the computer industry. The principles used to develop the B5500 were then applied to develop the first of the Burroughs Medium Systems products. The architecture of the Medium Systems V-Series was developed with the needs of the business community in mind. These needs focused more on the manipulation rather than the calculation of data. Most business applications were and still are programmed in COBOL, so the architecture was COBOL-oriented. A unique aspect of this architecture is its use of the decimal numbering system. This simplicity, more than any other factor, has made the Medium Systems V-Series computer systems easy to program, maintain, and use. Announced March 29, 1966, and delivered in '67, the B2500 and the B3500 systems borrowed important characteristics from the larger B5500 systems. These included operation under a fully integrated MCP, emphasis on multi-programmed operation, and the use of stacks to store subroutine parameters. The B2500 and the B3500 systems were also unique in that they offered two operating system options: the Basic Control Program, BCP, and the Master Control Program, or MCP. The BCP simply controlled stack job processing and straightforward input-output operations. The MCP, on the other hand, was the premier operating system that featured the scheduling and controlling of multi-programmed operations and some system housekeeping functions. When the MCP option was chosen with the B3500 system, up to 16 separate programs could be processed simultaneously. This multi-processing capability, along with dynamic resource allocation, system logging, and library maintenance features, significantly increased productivity. Probably the most novel offering with these systems was the magnetic tape cluster. Anyone who ever used a tape cluster in the 60s or 70s had a great story or two about them. One also cannot forget the card and paper tape readers, or that the MCP required only 10,000 bytes of core memory, and 150,000 bytes was the maximum allowed system memory. In 1970, Burroughs unveiled the first 700 series products. Ultimately spanning a performance range from the entry-level B700 to the powerful B7700, it included the B2700, B3700, and B4700 systems announced in 1972. Still designed in Pasadena, these systems represented the second generation of object code compatibility. Whereas the B2500 and B3500 systems had been small systems positioned between the B500 and 5500 in processing performance, the new B2700, B3700, and B4700s were called medium systems. The B2700, 3700, and 4700 systems provided benefits in many areas. The high-end B4770 system offered more than twice the B3500 processor performance. Much of this performance increase was due to the usage of Burroughs Common Mode Logic, or BCML. higher speed core memories, and optimization of fetch instructions. Advances in memory technology allowed the medium systems to feature up to 500,000 bytes of memory, a threefold increase over the B3500. The medium systems operating system was enhanced and renamed MCP-V. The basic control program option was dropped in favor of the more fully featured MCP. MCP-V allowed up to 80 programs to execute in an unrestricted multi-programming environment. Multiprocessing in the medium systems was further enhanced with a parallel multiprocessing feature, which allowed unrelated, independent programs to open and process in the same data file. In 1975, Burroughs announced the B2800, B3800, and B4800 medium systems. Designed in Pasadena, these systems were intended to extend the performance of the 700 series medium systems. Processor performance was doubled, and memory was increased to a maximum of 1 megabyte. To reflect enhancements in the operating system, MCP-VI was released. These systems represented the third generation of object code compatible medium systems products. In the early 80s, Burroughs announced the B2900, B3900, and B4900 systems. These systems responded to user requirements for increased processor performance and memory capacity. Concurrently, MCP-IX was released to provide increased memory addressing, pipeline architecture, and dynamic branch prediction enhancements. With the release of the B4955 system, the upper envelope of the medium systems began pushing into the large systems arena. Burroughs responded by creating new families of systems. The large and small systems were combined to form the A-series product line. The medium systems were poised for a similar announcement in 1985. With the introduction of the V-series architecture in 1985, Burroughs eliminated many of the medium system limitations. Some had imposed unreasonable constraints on hardware and system software development. The architectural strengths of the medium systems, character-oriented processors, decimal arithmetics, and addressing, were retained. Like the V300 processors, which marked the beginning of V-series hardware, the V-series MCP was designed to be a foundation for future software development. It provided a multi-thread operating system with new memory management, reentrant code, and significant enhancements in the areas of performance, reliability, capacity, and function. Memory addressability was increased to 36 quadrillion bytes, and up to 10,000 concurrent tasks and 10,000 disk devices could be supported. Throughout the mid-80s, users placed increasingly strenuous demands on their systems. As their transaction volumes exceeded the capacity of any one system, many users distributed their workloads across multiple systems. The boundless design of MCP-VS allowed the operating system to technologically leapfrog the available hardware. Hardware became the limiting factor in increasing the performance of the V-series. Fortunately, advances in semi-custom integrated circuit design and packaging technology enabled the Unisys Pasadena design facility to meet the challenge. The resultant V500 system announcement and delivery was the first V-series product from the newly formed Unisys Corporation. Another significant milestone was achieved in 1989 with the announcement of the first dual processor V-series system, the V560. The newest members of the V-series family and the first to be designed in Mission Viejo, the V400s, represent an evolution in the V-series. Characterized by a small footprint and substantial reduction in environmentals, the V400s incorporate the latest hardware technology while continuing to provide full software compatibility. These systems represent the 6th generation of object code compatibility. To users of both medium systems and V-Series, it should come as no surprise that these systems took top honors in the 1990 DataPro U.S. user rating of mainframes. V-Series systems captured top honors in 4 of the 14 surveyed areas: ease of operation, operating system, compilers, assemblers, and overall satisfaction. Through the leveraging of technology and the expansion of future capabilities, an exciting future truly lies ahead.